In this problem, we're dealing with the rate at which the temperature of coffee changes. That can be modeled by this differential equation. We have our differential notation on the left-hand side, so we know this is going to be a rate. And this is how C is changing with respect to time. And it's actually in terms of C, not T. C represents the temperature of the coffee in degrees Fahrenheit, and T is measured in minutes since the coffee was poured. Number 1 asks us how fast is the temperature of the coffee changing when the coffee is first poured at a temperature of 185 degrees. Then we need to answer this question: how fast is the temperature of the coffee changing when the coffee is 170 degrees? Notice we have our differential equation already, and we're told that that's the rate at which the temperature of the coffee changes. So to answer the first question, we're just going to go ahead and evaluate the differential equation for C is equal to 185 degrees. So that'll look like this: 0.054, and then in parentheses 70 minus 185. If you type that in your calculator, that turns out to be negative 6.21. The units are degrees Fahrenheit per minute. Go right back to the notation on the left-hand side. C is measured in degrees Fahrenheit, and it's in the top. And then T is measured in minutes, so that'll be your notation for the bottom. The next piece that we want to do is we want to take dC dt and evaluate that when C is 170. Same situation as before. This time we'll just replace C with 170 degrees. And if you type that in your calculator, you're going to wind up with negative 5.4 degrees Fahrenheit per minute.